variation of force and magnetic flux with respect to time. So if you consider this as a very simple transaction involving two magnets, two permanent magnets. When one magnet is placed in the field of the other, we look at an applied flux field. So we're applying a magnetic field from one magnet to the other. If the transaction wasn't time variant, the force acting between the magnets would actually be the same function as this. What actually happens is that the force that acts, that gives us the change in flux, actually takes time to respond. Go back to the, again, express in a simple way. It's almost as if you were lifting the ball back to the gravitational example, but it actually took a while for gravity to take effect. And that's exactly what happens in a magnetic transaction. It happens in very short time frames. This is a measurement from our lab, this is milliseconds. And we actually measured them at microseconds, depending on the material used. So what? You can vary force, and it is a known effect. The point about it is that when you look at it, in order to vary that force with respect to time, you have to do it at the cost of something. So what we did over the last 3 or 4 years is look at a full thermodynamic analysis of this reaction. We said, okay, so there's a variation in force or potential energy, therefore we must be draining or modifying some other energy source. Over the years, we've tested domain energy, we've tested heat energy, we've tested radiation energy. Basically, we've tested every possible form of ambient energy. And we got a big net zero. When I'm saying we tested it, we for example, last week drew 2,200 joules out of one of these transactions, just excess kinetic energy, out of magnets that had a domain energy of 0.2 joule, with no measurable degradation in the domain energy. Absolutely no measurable heat exchange in the result in a vacuum. The reason, the easiest way to look at this is actually to come back to the basics of ferromagnetism, which is the BH curve. If you consider the BH curve of a magnet, basically the area under the BH curve could be described as a domain energy of the magnet. And what actually happens during this tiny time period of a millisecond, the actual shape of the BH curve actually expands and contracts, but returns to the same place. So what you have is actually a simple way of looking at what we call transient BH bubbles. And as this magnet is moving around this BH curve, its actual total energy is varying. Okay, what drugs are we on? This is probably a fair question, where can you get them? The one thing about conservation of energy is that it's never been shown to be wrong. It is one of the singly most difficult to handle thermodynamic books. Do the calculations and say it works. It's an absolutely predictable, beautifully predictable process. And once we started to get into this, we began, as engineers, and as engineers are trained to do, to say, hang on, how true is this thing? How utterly reliable is conservation of energy? And there's really two areas, and I'll only discuss one of them, which you can look at. You look in the quantum world and the thermodynamics of an atom, and there are issues there. But probably more interestingly is what's termed the galactic spin problem. Because at the massive scale, thermodynamics should work just as equally as at the macro scale. And if you look at what's called the galactic spin problem, the galactic spin problem is the problem the galaxies spin a hell of a lot faster than they should. If you look at if you take all the known mass energy in the universe, you calculate how fast a galaxy should spin, you get this. If you take what it actually spins, you get a fundamentally different scale. How different? Well, in order for Newtonian mechanics and conservation of energy to hold, there is 96% of the universe that we just can't find. It's missing. You take exactly the same premise back to the Bohr model, and we've come up with one very simple and very elegant physics solution called the zero-point field of dark energy, dark matter. Say that, okay, what this is simply telling us is we won't question conservation of energy or Newton, because that's the heresy. What we'll do is we'll simply say, we'll up everything. We'll say that 96% of the energy, mass in the universe, is equally distributed all over the universe to make the numbers add. Fine, that's fine. It's never been done. Interestingly enough, about 3 weeks ago, 3 or 4 weeks ago, there was the latest gravitational lensing You know, there's hundreds of millions of dollars invested to look for this dark energy. And about 2 or 3 weeks ago, maybe 4 weeks ago, the latest results from gravitational lensing, we found it absolutely fantastic. We found we can actually see it. What they won't tell you is that you will get exactly the same gravitational and experimental results based on time variance within Newton's laws. The issue for us as a business, because I don't expect you to believe this, and certainly when you go into your exams next week, forget all of this shit, okay? Any more than that. Okay. But the issue for us about this is that the claim is so simple. We think this transaction you can set up in any lab in the world, you can swap, you can test it, you can do whatever you want, okay? And you will not be able to add the numbers. The thermodynamics of this transaction just don't work. So for us, the Orgo technology, as we call it, is really not a technical issue. It's not a scientific issue. The data is there, it's been tested in places all over the world. It's really about taking on a mindset. It's about taking on an academic mindset, it's about taking on a scientific mindset, and it's about taking on a public mindset. The first thing to say is that anybody who lays a claim at the door of conservation of energy is a wacko. You're immediately off the charts. You're a heretic at best. You're probably a con man. We went around for 3 years, very aware of this. We're all qualified engineers and scientists, very aware of this, kind of quietly knocking on people's doors, going, "Listen, we're just dumbass engineers. Maybe you can show us the problem. You know, maybe just show us where we made our mistake in the calculation here." And we got subjected to ridicule, closed doors, and that treatment continues today. But being who we are, which is abnormal at many levels, we decided what we would do was turn the game around. We'd go out and actually slap science on the face. So in February last year, after we'd been just finished with Cambridge University, actually, who had tested and refused to publish, we said, here's what we need to do. We need to find a different way to take this platform into the public domain and a different way of obtaining validation. So what we did in August of last year, in a classic Steorn move, is something completely unfair. We took full-page advert in the Economist, advertising for scientists to come and prove us wrong. It was an incredibly successful event from us, and the traditional media, we got Sky and all this kind of stuff. The interesting thing for us is that the mainstream media reaction was very balanced. They wheel us on, we chat about it, wheel on scientists saying, you know, but maybe. But actually during all of this, we had scientists ringing up, threatening physical violence. I'm not joking. These are credible scientists, okay? We got cries of complete charlatans, fools, idiots. And obviously it's fraud. Obviously these guys are frauding. Somewhere in this there has to be money, because everybody knows you can't defy the laws of physics. Which is a bizarre reaction. You can expect this in internet forums. When you get this from, you know, relatively credible scientists, you have to raise an eyebrow about it. The purpose of what we did was, in a very real way, to get the attention of science. So in all of this, we had about 5,000 people apply, actually tested, and about a couple thousand qualified engineers and scientists. 22 people actually started testing. There's 21 PhDs ranging in the biggest and best institutes around the world, and they're pretty experienced. They began, first of all, with a peer review, which started January 9th, and now physical testing and lab testing and so on. And fundamentally, whether you believe this or not, you shouldn't believe it without actually looking at evidence. The real question and the role of the jury is to answer one very simple question, which is this one. And I'll leave you with that. Thank you.